today to discuss a whole range of issues around refrigerants, end of life, and other refrigeration and air conditioning issues. As an industry, we have been very successful when it's come to environmental performance. We still need to cut more emissions, move towards net zero, and reduce energy use. Today we're going to discuss all those things. We're going to divide it up into 4 sessions, starting with equipment.
Well, I think in terms of technology, it's been really pleasing to see the last 10 to 15 years, the developments that the industry has made. It's been leaps and bounds, but that doesn't mean that it's finished yet. In terms of HFOs, there's a big separation between safety and efficiency and global warming potential as well. So we're seeing with a lot of products, particularly low pressure equipment, moving to refrigerants such as 1234ZE, which has a GWP of less than 1. So for low pressure equipment, it's quite easy. But the challenge that we have as an industry is incorporating this into high pressure equipment, where the safety design and manufacturers designing products to a safe standard, as well as training the industry on how to deal with these products, is the challenge moving forward. And at the moment, R32 is playing a role with a balance with the things I spoke about, safety, efficiency and GWP. But it's how we can incorporate more HFOs into that space in the future, which will be challenging. Some standards could have to be created to support that or updated to support that. I think some of the main barriers is training and education, but also that safety standards and getting some consistency there around how equipment can operate at a high pressure HFO situation, and then how can we incorporate that into the market from a training and exception point of view.
Like when we talk about why we don't have more high efficiency equipment, because we tend to put new high efficiency equipment into new buildings. But what about replacing aged equipment in existing buildings? Because existing buildings and I have a saying, greenfield is 1% of nothing, but brownfield is 99% of everything. If we could somehow make landlords understand that the existing equipment they have are second-hand clunkers, and if you were to replace it with new equipment, it would actually be a more profitable thing for them. It would lower their running costs. It would make their tenants happier. If you could actually really proof that up, then they would have no problem putting in new equipment. But we as an industry aren't extracting the data that we need out of these buildings to actually make the business case. I think we really need to be very clear on the business case of why we should put in new equipment. The one demand that I see from landlords and tenants is that they just want really 5 outcomes, and that they will do whatever they feel they need to do to get those 5 outcomes. And it's tenancy experience, better tenant experience, less breakdowns in the building, less running costs, and maybe CapEx costs as well, less energy and water consumption, and less operational risk and cyber risk. That's what they want. But you've got to give them the business case that that's the outcome they're going to achieve. If you start talking technology for technology's sake, and we as an industry don't always do that very well. So, the finger always points back at us as to what we could be doing more. And I think it's showing people that we can deliver you those 4 outcomes, and then off the back of that, you're going to get an improved environmental, social governance outcome.
But the market demand's really driven by manufacturers, our education, our marketing. And we see that all the time. If you have a fad on one of your products and you market it really well, that demand pulls through when selecting equipment. So I think as manufacturers, we play a really key role in educating consumers to what's the benefit and what's the cost of certain features and products. So there's been a huge demand for heat pumps throughout Europe. And that's really come from energy prices and certain governments there phasing out gas, which is really pleasing for us as a lot of product from Europe filters to Australia. We're the benefits of this reward. And because the market's so large, there's been a lot of R&D put into this space So there's some pretty good kit out there now, from a heat pump chiller, 4-pipe chillers as well at the moment. But we are seeing a lot of developers, in particular for their ESG strategies, trying to electrify their buildings. So move away from gas boilers. So from a commercial setting, it's probably taking off a little bit quicker. From a domestic setting, it'll be interesting to see where the market goes in terms of a heat pump connected to a big hot water tank, and how efficient that is, and how quickly you can get a cost benefit from that approach. Yeah, I think things like the NCC and GEMS have done really well to increase efficiency of products and then how they're installed. So we've seen GEMS, a lot of new products being added to the program. So we saw it recently with the above 65 kilowatts units added to the air conditioning MEPs, but also other products being introduced into the GEMS program as well. But that's great. We can have really efficient products in the market, but if they're not installed correctly, if they're not sized correctly, or if they're not maintained correctly, the products can become from efficient to non-efficient pretty quickly. But the more that the installation and sizing can be added and incorporated into some of these codes is really important to make sure our equipment runs efficiently and effectively. And probably just to sum up that as a whole, I think the NCC and GEMS harmonisation is very important. And for it to be effective and efficient, they need to be aligned. Or we're going to have a situation where each one contradicts each other, and then there's some challenges come from there. So there was recently a new residential standard to put a base around how to do sizing, which has been incorporated domestically. Commercially, we've always been pretty good as an industry, where we're seeing design engineers sizing this equipment that makes it a little bit easier. But it's trying to find that trade-off of certain cost-cutting measures to have smaller capacity equipment put in, which might not run as efficiently because it's undersized, versus the initial CapEx cost.
I think Kyle's given a great answer, that the glass is half full. Let me just expound a little bit on the glass being half empty. Same glass. And I guess my point would be that the NCC and GEMS and really all of the programs we've had to date have focused on efficiency at point of sale. So while there is some flow-on effect, installation's not covered, sizing isn't covered, maintenance isn't covered. So I'm not disagreeing that for a whole variety of reasons, including the licensing of tradespeople, and better understanding of environmental consequences and energy consequences, a certain decision that the industry has improved over the last 10 or 20 years. This area, I reckon, about what actually happens in building, not the technical energy efficiency of GEMS and of MEPs, but rather the delivered energy efficiency, is the most cost-effective, practical thing that we as an industry can do to really have an impact on the environment and on our electricity demand today. It's something that can happen right now. I do think we need some government intervention, and I'm not talking about money, but I'm thinking about, as well as industry intervention, targeted information campaigns and other things to help facilitate this flowing through the economy. These are damn close to free wins, and we should take advantage of them.
One of the things that's delayed us in publishing information about the, the quality of different types of chillers, package units, based on their mean time to failure. We were very concerned that if we published the data that we have and said, oh, but this split system is better than this one in terms of serviceability or whatever, we would be doing the wrong thing by the manufacturers, because a lot of the equipment's quite good, but we need to quantify the quality of the installation, the environmental factors, so it's unfair to say this type of unit is not good based on our service data because it was installed incorrectly. And I think that goes to the point that you're making, that it's not just a matter that the equipment is really good, but if it's not installed correctly or it's undersized, it's not going to perform. So it's unfair then to say that unit, and until we can isolate the environmental factors and make it a level playing field, it's very hard to put information out there that says, oh, this type of equipment performs better than this one. And I tell you, it's been a really big challenge for us because we've wanted for years to publish some of this information, but we've held off because we haven't yet quite figured out how to isolate the environmental factors of the installation. And all I'm saying is that just reinforces what you just said, Greg. As soon as we can make sure that we can do that properly, we would love to publish some of the information so people then can make their own decisions.
Quite often we'll come across particular projects where customers are going to a smaller size machine just to be the most cost competitive. And all considerations of efficiency and energy go out the window. So how do you address that? No, I don't have the answer to that, but it's something that's worthy of considering.
One of the challenges with the current approach to the NCC, particularly for residential buildings, but that includes not just houses but apartment blocks and the like, is that it focuses on the efficiency of the equipment but does nothing about the size of the equipment. So if I've got a whopping big space and I put in a small, highly efficient unit that maybe will cut it when it's 30 degrees, but by the time it hits 33, it's running at 100%, you lose the efficiency. As the building developer, I get extra credit for that because it's a highly efficient unit, even though it's undersized. So that the possibility of perverse outcomes in that situation, exactly along the line of what you're saying, but even more so because they get credit for it in terms of the overall building efficiency, is really there. So, role for government, we can certainly debate. Certainly where government is already intervening, it's absolutely imperative that government provides the right signals and isn't in a situation where they incentivize building developers to stick in undersized, highly efficient equipment which doesn't deliver what people expect and pay for.
They need to almost take a whole of life cycle perspective. So, the unit's got to be, a high efficiency unit, it's got to be sized correctly, it's got to be installed in a responsible way, and then it's got to be maintained in a reasonable way. All those factors, if you tick those boxes, then you can evaluate the efficacy of the different systems to decide maybe this is the best one. That level playing field and building that level of sophistication into our codes and standards will take time. But I think that's definitely the path we should be on, to your point about, and the only other point about, is there a solution to people undersizing? And look, this may be controversial, but I feel ultimately you've got to decapitalise the industry. In other words, put something in, you're not paying any money up front, so you're going to make the best decision on what's going to last the longest, which is a whole of life cycle perspective. But at the end of the day, people expect to get paid when they do the job, so you can channel funds that are looking for an investment return. So it's about decapitalising the industry, delivering it as a service. But that's going to take a long time to bring about, but I think that's the future. And you've seen other industries decapitalise, and you can see the benefits that's been accrued to them.
No one pays any attention to the embodied carbon or the actual installed cost, and the totalitarian or the total carbon footprint of that installation through manufacturing of the componentry, the refrigerant, energy consumption, maintenance, end of life. It's a major challenge.
I think just to go a little bit further, from a manufacturing product side, there has to be a line drawn with where embodied carbon stops, because you can go down a very big rabbit hole where you can't track it. When you look at all the componentry that's put into building an air conditioner or any HVAC equipment, if you have to get to componentry type levels from embodied carbon, it's next to impossible. So having a line drawn in the sand somewhere where what's included and calculated in any type of embodied carbon approach is really important.
Embodied carbon matters as we increasingly use renewable energy. So at that point, the electricity demand that our equipment supplies matters less and less over time. That's the theory. So what matters more? Refrigerant emissions matter more. Operational emissions, other things, as well as the carbon that was implicit in the equipment when it was first installed and manufactured. The challenge with that right now is the push for embodied carbon and making that assessment and having that be a factor today is presuming that we've already done the transition to renewable energy, and we haven't. And so while I think embodied carbon is a good area of exploration and something to start working on, I think it is critically important that we don't focus on it now and take our mind away from maintenance, from installation, from sizing, for those things where there's massive abatement potential today. I know numbers of the embodied carbon people have said, because I've been on meetings when they've said this, operational emissions, we have that under control. And quite frankly, they don't know what they're talking about. As we know around this table, operational emissions, particularly for poor maintenance and sizing and installation, as we've talked about, are not under control. And it's cheap abatement. Before we're worrying about tracking the carbon implicit in a component to an air conditioner, let's get that sorted first.